Multi-WAN configuration allows you to classify, segregate, and route traffic from LAN devices to different WAN interfaces. For each LAN device or application, you can select possible WAN interfaces and configure policies for dynamically routing traffic between the LAN and WAN. We'll show you how to define the various multi-WAN policies that determine how your router maintains or switches its WAN connectivity. Log into your Wireless AirLink router and navigate to the Networking tab and refer to Multi-WAN Policies and Multi-WAN Policies again. This is where you can configure the top-level rules for data traffic management between LAN and WAN. AirLink OS has two default rules already defined: the default routes for IPv4 and IPv6 traffic. These two rules allow you to define the devices used to carry IPv4 and IPv6 traffic. They use the default system WAN zone. You can edit the WAN output fields to use other zones. To configure a rule, start by setting it to enabled and give it a name to identify it. LAN inputs specifies the source of the traffic. If left blank, the policy applies to all traffic. WAN outputs specifies the ordered list of interfaces the traffic can be carried over. Default policies use the WAN zone to define the default device order. The default device preference is Ethernet, Wi-Fi, cellular, and finally USB interfaces. To change the order, you can either select interfaces in priority order or you can define a new zone. Zones are configured under networking zones and system zones. Services specifies a protocol or port number to identify the traffic. If left empty, all traffic types will be matched against this policy. You can configure services at networking zone settings and services. Source IP and destination IP specifies a source or destination to match against this traffic. You can enter an IPv4 or IPv6 IP address and AirLink OS will validate it. Note that if both IPv4 and IPv6 traffic is to be selected, two policies must be created. Destination FQDN is where you can specify a fully qualified domain name instead of a fixed destination IP address. To use a destination FQDN, clear the destination IP field. Click the field to select a pre-configured FQDN or click Create to create a new FQDN entry. You can also create a new FQDN entry under Zone Settings and Fully Qualified Domain Names. Lastly, we have Priority. This defines the order in which policies are evaluated in ascending order. For example, if you create a rule with priority 100, it will apply first and override the default 998 and 999 policies. Each policy must have a unique priority. AirLink OS does not allow policies with identical priorities. Confirm your configuration under Status/Monitoring, Networking, and Multi-WAN. This will display your configured policy routes and priorities. Now your router is ready to route traffic as you specified. Note that when selecting a WAN interface from the set of interfaces defined in WAN outputs, whether it be for the default IP traffic or your own policies, the default ranking is based on the following: whether the interface is connected or not, meaning it has an IP address, the user-defined or system default order for traffic and link validation, which means whether the interface has internet connectivity. The link validation is configured at the Networking Network Watchdog page. To further refine how the system determines which interface is usable, you can apply additional rules to your multi-WAN policies beyond basic network connectivity. These rules include roaming avoidance, signal strength, connected Wi-Fi, and current vehicle speed. Let's start with roaming avoidance rules. This asks the router, is the cellular device actively roaming? Enable will activate this rule. Importance is either mandatory or optional. When the rule is set to mandatory, the WAN interface must never be used if roaming. Disable to make the rule optional. When the rule is optional, the WAN interface should not be used if roaming and another WAN interface is available. If no other interface is available, use this optional interface even if it is roaming. Apply this roaming rule against the specified WAN policy next. Apply this rule against the specified interface used in the WAN policy configured in Applies to Policy. Note that this must be a cellular interface. Last, you can constrain the roaming policy to a network operator so that the roaming rule applies only if currently connected to the specified provider. Signal strength rules can be configured here. Like the roaming rules, set the enable and mandatory options as needed. Apply this signal strength rule against the specified WAN policy. Next, apply this rule against the specified interface used in the WAN policy configured and applies to policy. This can either be a cellular or Wi-Fi interface. Usable. Unusable signal strengths can be configured in either abstracted signal bar strength or RSSI. Click Create Signal Strength Rule to configure and add a signal strength rule. Wi-Fi SSID rules are next. Again, like the previous rules, set the enable and mandatory options as needed. Apply this SSID rule against the specified WAN policy. Apply this rule against the specified interface used in the WAN policy configured and applies to policy. Note that this must be a Wi-Fi-WAN interface. The rule becomes active if the Wi-Fi client is currently connected to one of the specified SSIDs. See Wi-Fi SSID database for the list of SSIDs available to be added to this rule. To complete this rule, set the traffic policy when SSID matches. Options are either forward, which means the interface can be considered usable if connected to the specified SSIDs, or you may block, which means the interface will not be usable if connected to the specified SSIDs. Lastly, we have vehicle speed rules. Once more, set enabled and importance as needed. Apply this speed rule against the specified WAN policy. Apply this rule against the specified interface used in the WAN policy configured and applies to policy. Threshold is read in miles per hour. When the vehicle speed is above this threshold, the speed rule will inhibit traffic on the selected WAN interface. Recovery time is read in seconds. Once the vehicle speed has exceeded the threshold and data traffic is dropped, recovery time specifies how long the vehicle must be below the speed threshold before traffic is permitted on the selected WAN interface. That sums up our configuration and options for multi-WAN policies on Sierra Wireless AirLink OS. We hope you found this video helpful and welcome you to subscribe to our channel for more videos like it. Thank you.